Assalamu alaikum wa rahmatullah. Good day, everyone, and welcome to my channel, Physics with Silent Kano, where you can learn physics and solve physics problems. In today's video, we will look at capacitor. A capacitor. What do we mean by a capacitor in physics? A capacitor is a device or electronic component. We say it is an electronic component because we use it in electronic circuits. And its main purpose is that it stores electric charges. This is why we said a capacitor is a device or an electronic component used for storing electric charges. Q. Electric charges is denoted by Q, and Q is measured in coulombs. Coulombs is the SI unit of electric charge. Now, because electric charges carry electrical energy, we say that because charges are carriers of electrical energy, we can also say that a capacitor stores energy. And in later videos, we will see the formula for calculating the energy stores in a capacitor. Moving on, now how do we recognize a capacitor in an electronic circuit? If we are given a circuit and we want to identify a capacitor, how do we do that? It has some symbols. This is why we say some capacitor circuit symbols. Now it depends on the type of capacitor. We have a few of them here. If you have a fixed capacitor, then the symbol is this one. You will see that these lines, these vertical lines, are of equal length. They are of equal length. When you see something like this, it is a capacitor, and the capacitor value is fixed, meaning it does not change at all. If it is 20 microfarad, this 20 microfarad will not change. Variable capacitor is a capacitor with different value of capacitances. The capacitance value is not fixed, it can change. So we draw the same symbol, but we put an arrow across it. This tells you that the capacitance value changes. Then we have another type of capacitor which we call electrolytic capacitor, and this is its circuit symbol. Electrolytic capacitor has electrolyte and electrode, as we know in electrolysis. Now that we know that a capacitor is a device that stores electric charges and, of course, electrical energy, then how do we measure the ability of a capacitor to store charges? The measurement of that ability of a capacitor to store charges is what we call capacitance, and is denoted by capital letter C. So we say that the capacitance, denoted by capital letter C, of a capacitor is a measure of the ability of the capacitor to store electric charges. It means that a capacitor with high value of capacitance is expected to store more electric charges than a capacitor with low value of capacitance when the two capacitors are connected to the same potential difference, meaning the PD across them is the same. If you are given two capacitors, let's say this is capacitor A and this is capacitor B. Okay, they have different value of capacitances. You want to know which one will store more charges. Maybe this is 50 microfarad and this is 20 microfarad. Now if you want to know which one will store more electric charges when the same potential difference is applied across them, then you look at the value of capacitance. The one that has more capacitance, that is this one with 50 microfarad, will store more charges than this one under the same potential difference when the same voltage is applied across them. So again, we say that the capacitance C of a capacitor is a measure of the ability of the capacitor to store electric charges. The SI unit of capacitance, because capacitance is a physical quantity, it has unit of measurement, and the SI unit of the capacitance is the farad, denoted by capital F. But this farad is a very large unit. So we say that because farad is a very large unit, capacitance values are commonly given in microfarad. This is the symbol nanofarad. This is the symbol picofarad. This is the symbol. These are small unit, extremely small unit. Nanofarad is smaller than microfarad. Picofarad is the smallest of all. Now, here is the interconvertibility of the unit, the conversion factor. If you are given in microfarad, then know that 1 microfarad is equivalent to 10 raised to the power of minus 6 farad. This means that if I have a capacitance value of 20 microfarad, then is equivalent to 20. I will just multiply it by this conversion factor, 10 raised to the power of minus 6. Now I have changed it to farad. And then 1 nanofarad, look at it, the n is in lowercase and the f is in uppercase. This should be noted. 1 nanofarad is 10 raised to the power of minus 9. So if I have 20 nanofarad, this is equal to 20 times 10 raised to the power of minus 9. I take this conversion factor. Okay, then if I am given 1 picofarad, the conversion factor is 10 raised to the power of minus 12. So if I have 20 picofarad, then this is 20 times 10 raised to the power of minus 12 farad. Okay, now what is the formula? You may be curious to know the formula you can use to calculate the capacitance of a capacitor. We have a general formula that we can apply to any kind of capacitor, and we also have some specific ones. We also have some specific formulae. We will start with the general one. The general formula, the capacitance formula in bracket general. We say that there is a formula connecting capacitance denoted by capital C, potential difference or voltage denoted by capital V, and the charge denoted by capital letter Q. Sometimes you may use small letter q. In some books they use small letter q, but capital Q is more common. The charge Q stored in a capacitor. These three are related by the formula capacitance C is equal to, as we can see, charge Q divided by the voltage V. As you can see here, we have here a capacitor, and then you have connecting wires here, two connecting wires here, and these are connected to, this is a negative terminal and this is a positive terminal. One end of the capacitor is connected to the negative charge, the negative terminal of a battery. The other one is connected to the positive terminal of the battery. V is the voltage of the battery, and of course the PD across the capacitor. C is the capacitance of the capacitor, and Q is the magnitude of charge stored in the capacitor after some times when it is fully charged. Okay, because if this one is a parallel plate capacitor, then this end will store a charge minus Q. It will store negative charges here, and then this one it will store positive charges here. The total charge is given by this Q. Now, how is Q, C, and V related? They are related by this formula. It says capacitance, this C, is equal to charge, capital Q, divided by V, voltage. Now in symbol, you instead of capacitance, you just use capital C is equal to, instead of charge, you use capital letter Q divided by capital letter V for voltage. Sometimes you know the capacitance, but you want to get the charge, so you can still use this formula and make Q the subject of the formula. You simply multiply both sides by V. When you do that, this times V, this times V, V cancel V, and you have Q will be CV. So we say also Q is equal to CV, and this equation 2 comes from equation 1. Again, from equation 1, sometimes you may know C and Q, but you don't know V. So you can make V the subject of the formula. So uh, you interchange this, and you have V is equal to Q over C, and this is equation 3. Okay, now how do we use this formula in solving problems? How do we use this formula in solving problems? Now we are going to see some examples here. The very first one before us says a capacitor stores a total charge of 150 microcoulomb when a potential difference of 100 volt is applied across its ends. Calculate the capacitance of the capacitor. So, in solving this problem, we try to understand the problem first. The first thing we are given here is the total charge in the capacitor. The second one is the PD across the capacitor. And our target variable is the capacitance of the capacitor. This value, this very one, is from the unit microcoulomb. Coulomb is the unit of charge. So this value is our capital Q. And then this 100 volt, okay, is our V, the PD across the capacitor. Then capacitance of the capacitor is our target variable. This is C. So we now say solution. Now we bring out the parameters we are given. First, we are given capital Q, and our capital Q is 150 microcoulomb. Remember, microcoulomb is not the SI unit of charge. Okay, so we have to convert it to the SI unit. So this should be 150. The conversion factor for micro is 10 raised to the power of minus 6. Now it is in coulomb. Next, our V is given in 100 volt, and this is the SI unit, so we don't need any conversion here. Next, we write the formula that relate Q, V, and C. Okay, we may wish to write that C is equal to question mark, meaning that this is our target variable. Okay, the formula is C is equal to Q upon V. That's equation 1. So this is equal to the next one. After writing the formula, then we make substitution. Our Q is this. This is 150 times 10 raised to the power of minus 6 divided by our V is 100, so we have 100 here. Okay, and remember the capacitance of a capacitor is measured in farad. Once you make the substitution, remember the unit is farad. Okay, bring your calculator here, or if you like, you may not need a calculator here. 100 divided by 150 divided by 100, this will be 1.5, and then you have times 10 raised to the power of minus 6 farad. Remember, this 10 raised to the power of minus 6 is your micro, is the one we say is micro, so we can say this is equal to 1.5 microfarad. That's it. We have solved example 1. Moving on, we have the next example here, example 2. Okay, example 2 says that a voltage of 120 volt is applied across a capacitor of capacitance 500 microfarad. calculate the charge stored in the capacitor. Here the parameters we are given V, and this is the capacitance of the capacitor, and then we identify our target variable. Our target variable is the charge, because the problem says calculate the charge, and the charge is capital Q. So let us bring out this as quickly as possible. Solution: our V is 120 volt. Then this is C. Our C is 5 500 microfarad. Then we have to convert this to farad. So this is 500 times the micro here. The conversion factor is 10 raised to the power of negative 6 in farad. Then what is our target variable? Our target variable is Q, and we don't know this Q, so we put a question mark. Then we bring the relationship that says Q is equal to C is equal to Q upon V, from which we can make Q the subject of the formula. You simply multiply this by this, and then Q becomes the subject. So Q is equal to CV. Now the next thing is you make substitution. The next thing is you make substitution. Let's see, we can substitute here. This is equal to, what is our C? Our C is 500 times 10 raised to the power of negative 6 in farad, multiplied by our V. Our V is 120. Okay. You now bring your calculator here. If you bring your calculator here, you can press 500 500 5. I want to make sure that you can see the calculator. Okay, so if you press 500 exponential, do you have exponential? Okay, yes, negative 6. So you have negative 6, then multiplied by 120. So you have 120 here. Then press equality sign. And what is the result? 0.06. So it means I have 0.06. What is the unit of charge? Charge is measured in coulomb. So this is 0.06 coulomb. Moving on, the next example here with us is example 3. Example 3 says that uh, what potential difference must be applied across a 20 microfarad capacitor. Okay, from the unit we understand that this unit is for capacitance. Microfarad is for capacitance, so this is capital C. In order to store a charge, okay, we are told this is a charge, so this is capital Q. So what potential difference? Potential difference is another word for voltage, so this is V. Our target variable is V. So we bring out what we are given in the problem. Let's say solution. Uh, we are given C. Our C is 20 microfarad. Then remember this 20 microfarad, we can change it to 20 times 10 to the power of minus 6 farad. The micro here is times 10 to the power of minus 6. Okay, next our charge Q is 60 microcoulomb. Again, this one we can change it to 60 times 10 raised to the power of minus 6 coulomb. Okay. Our target variable, bring our target variable. V is our target variable. We don't know V, so we now use the formula again. C is equal to Q upon V. Now the next thing is we want to find V, so it has to be our subject of the formula. So simply interchange this. easily, you will just have V is equal to Q upon C. Now you can substitute Q. What is Q? uh, Q has this value 60 times 10 raised to the power of minus 6 divided by what is the value of C? C is 20 times 10 raised to the power of minus 6. Clearly, 10 raised to the power of minus 6 cancels 10 raised to the power of minus 6, and 60 divided by 20 will give you 3. So this is 3. Now, what is the SI unit of the potential difference? Is volt, denoted by capital letter V. With this, we have solved the second problem. The third problem, of course. Now, we go to the fourth problem. The fourth problem, in the fourth problem, we are told that we have these circuit diagrams, and at least one parameter is not given. Example 4 says calculate the unknown quantity in each of the following circuit diagrams. If you look at the circuit diagram, at least one of the three parameters we know is not given. Here 120, you have the capacitor, it is connected to a battery. Here the voltage of the battery is 50 volts, so this means the PD across the capacitor is 50 volts. So here a solution, let's solve this one. Our V is 50 volt. Okay, our V is 50 volt. Then the capacitance of the capacitor is not capacitance of the capacitor. This is nanocoulomb. Coulomb is for charge, so 120 nanocoulomb is for the charge. The charge is capital Q, so our Q is 120 nanocoulomb. Remember, nano is 10 raised to the power of minus 9, so this is 120 times 10 raised to the power of minus 9 in coulomb. Okay, what parameter is not given? It means the capacitance of the capacitor, C, is not given. So let's find the C. We say C is equal to Q upon V, our formula. Now we can substitute. Q is 120 times 10 to the power of minus 9 in coulomb divided by V, and our V is just 50 volt. Okay, you can just keep the 10 raised to the power of minus 9 and then divide 120 by 50. What do you have? 120, let's see, 120 divided by 50, this will be 2.4. So we have 2.4, then you bring times 10 to the power of minus 9, and then remember this C, capacitance of a capacitor, is measured in farad, so this is equal to 2.4. Then remember again that 10 to the power of minus 9 is nano, so you have 10.4 nanofarad. Now let's take the next circuit diagram. In the next circuit diagram, the voltage of the battery is 100 volts. So solution, our V is 100 volt, and this is picofarad and is the unit of capacitance. So this is C, this is V. So our C is 500 picofarad. This is 500 times pico is 10 raised to the power of minus 12. So we have this. Okay, what quantity are we not given? We are not given the quantity of charge stored in the capacitor. So our Q is unknown, is our target variable. We use the formula again. C is equal to Q upon V. Now, if you want to get Q, multiply both sides by V so that your Q is equal to CV. And this is equal to, now substitute C is 500 times 10 raised to the power of minus 12, then times V, and V is 100. Okay, now look at, you bring your calculator now and press uh, 500, 500, then exponential, press exponential, you press this one, and then minus 12, so you press here, minus appears, and then you have the 12 here. Okay, then you multiply by what we are given here, 100. So you multiply by 100. Okay, you see this will be 5. It means 5 times 10 to the power of minus 8. So we have here, this is equal to 5.0 times 10 to the power of minus 8. Now what is the unit of charge? Charge is measured in coulomb, so we have this in coulomb. Then next, solution. The final circuit diagram here says, here you can see the charge is given, now we look at the final circuit diagram. In the final circuit diagram, we can see that the charge is given, the capacitance of the capacitor is given, but we don't know the PD across the capacitor. So we are going to say, okay, our C, capacitance of the capacitor, is 580 microfarad, and this is 580 times 10 raised to the power of minus 6 farad because of the micro. And then the charge Q is equal to 150 microcoulomb, and this is 150 times 10 to the power of minus 6 coulomb because of the micro. Again, we use our formula. It says C is equal to Q upon V. Now we want to find, I forgot V question mark, our target variable. We want to know it. So C is equal to Q upon V, but we don't know V now. So we simply interchange this. We bring V here, we take C there. So our V is equal to Q upon C. Then we substitute the values we are given for Q and C. Our Q is 150 times 10 to the power of minus 6 divided by our C. Our C is 580 580 times 10 to the power of minus 6. So clearly you see that 10 to the power of minus 6 cancels 10 to the power of minus 6, so you divide 150 by 580. Okay, let's see that. 150 divided by 580, and this will be this is 0.2586, and on the voltage. V is measured in volt, so correct to 2 decimal places, it should be 0.26. So we have 0.26 volt. Okay, this is the end of today's video. In the subsequent videos, we will see the capacitance of a parallel plate capacitor, arrangement of capacitors, series and parallel arrangement of a capacitor, and also the energy stored in a capacitor. Thank you for watching, and stay tuned for the next. Assalamu alaikum wa rahmatullah.